Hi there. So this talk is about integration, contract testing, and its potential for API development and maintenance. My name is John Roach. I'm a senior software engineer in American Greetings. This slide show I'm going to show is going to be on my website, so feel free to pick it from there. And I hope to also post, give a link to it from my Twitter, and that's my Twitter handle. Feel free to go there or follow stuff. So everything starts with a story, right? The story is very simple. We had this one team that was working on a zoo application, let's say, and so what they had monoliths, and they said, okay, let's change this. We need to take a different approach for certain reasons. Who knows? But the main thing is that they wanted to go with a more modern architecture, say with microservices. So they separate out these concerns, and then they create these small APIs. And here there's a zoo API and there's an animals API. And so the team had productive meetings. They discussed and nailed down the communication between these services, what's the requirements. They did some documentation. They create these end-to-end tests. To cover the happy paths, and they went on to their merry way. So the developer life cycle looked like something like this. So when a new developer came in, they sat down, read some docs on how to develop their respective API for their team. If they're on the Zoo API team, they'll be working on the Zoo API team, and they'll read Zoo API documentation. And then they'll update the test if they're doing TDD. Sometimes that's reversed, but it happens. So they first update the test, they write the code, and they run the tests. So all was well. Well, the thing is that something broke in production, and the zoo app failed. Zookeepers no longer knew which animals were in which pens. Tigers, they didn't know even how many tigers they had in a pen, so that kind of went crazy. And they needed to do a rollback of the deployments, and they went to a better state. So let's go over a little bit what happened. So I said each application, each API developer would be more concentrating on their API. So like Bob from Zoo API would actually just concentrate on the Zoo API. He would only update his own tests. He would update his own code, and he would run the tests for his API. And same thing with John. He worked on the animals API. He only read the documents for the animals API, and he ran the tests for that and coded for that and whatnot. So the change they actually found, the error they found is actually very, very simple. Someone changed the status from no to false because it made more sense programmatically, right? Why would you use a no string instead of a false string? So, something broke. And then they have a retrospective, like every good agile team. They sat down and said, okay, how can we avoid this in the future? So they talked about some of the good stuff they did for this, that could have avoided this problem. And also they talked about, okay, what can we do a little bit better? So some of the things they talked about is they say, okay, actually we do have good documentation, right? We have extensive documentation here. And then regarding the APIs, right? They did specify that they had good documentation for the APIs. They said, well, actually, we write a test for the API. So each API would actually have its own unit tests, which is pretty awesome. We like tests. And then they did talk about end-to-end tests, and they kind of worried because end-to-end tests only covered happy paths. And there was a reason for that because basically the end-to-end test took a long time. And I'll get into that a little bit more. But that's the reason why they kind of limited all their end-to-end tests to the happy paths, because if they included everything, it would take too much time. And they said, okay, we have good daily stand-ups, but no one really talked about this change. No one really communicated that, so it got missed, which happens. And then some people said, hey, we have code reviews. Why wasn't this caught in code reviews? Well, code reviews is actually not a tool for communication. I mean, it is a tool to review your code, but it doesn't mean that you're documenting that change. It doesn't mean that you're actually communicating that out. There might be someone that might have missed that code review, especially with large teams across multiple API teams, especially if they're siloed. That might get missed. So it looks like no one actually caught this change, which happens. So they thought about, okay, what might be the possible solutions. So they went over a couple options here. They said, okay, let's write more end-to-end tests. I mean, it does make sense. I mean, you might start, right, instead of getting only the happy paths, you might actually start, getting to these edge cases and writing those. But again, you're talking about these long these tests that take a long time. And I said as before, I'll get more into end-to-end tests later. And then they said, okay, let's write more documentation. Let's actually, add more stuff. But the thing they noticed is that their actually documentation was almost like 200 pages long. And it was a couple of levels deep. So after a while, like any new developer that came in was actually missing some stuff. They were actually have to drill down to all these, long-winded documentation about how an application works, and things got missed. But still, it doesn't mean that they cannot write it clearer, right? So that came out of retrospective, and they said, okay, let's do more meetings, right? More meetings definitely helps. It's all solution to all. Well, a lot of cries said, no, please don't do that. We have enough meetings. So that kind of died down. The idea kind of got thrown out the window. So the question is, okay, what can we do? Well, how can we avoid this problem? And so whatever solution that comes out was decided that we need a solution that facilitates communication for changes that will affect communication between the services, right? So if the communication between the services changes, we need to capture that as soon as possible. And they came up with 3 bullet points, right? Which should be captured with the solution. The first one is misunderstandings from the consumer about endpoints or the payload. The second thing is breaking changes by the provider on the endpoints or payload, and bugs in the consumer, right? So these are the 3 main things that we would like to capture. A solution that will capture only these with minimum effort, with faster time response, right? You don't want to lose too much time in your tests. You want to, fast feedback as soon as possible. So let's see, right? What can that be? So I want to show you a little bit of overview about automation, test automation, and this actually belongs to Martin Fowler. He actually, does awesome writings. I definitely suggest you to read them and find them online. He has cool stuff. So I really like this graph because actually it does summarize the whole test and what types of tests you can do. So there's like unit tests is very limited to these small components. So like repositories, domain, and you have your integration tests that actually include some two or 3 nodes that you might need to integrate and test. But please do note that I actually require both of them. So you have your component tests. You cannot actually do this all the time, especially if your code is highly integrated. It's hard to separate out, some of these components out. But still, that's a solution too if you wrote your code with smartly. But then and then there's an end-to-end test that is like capturing all of the frame and includes all of these, right? However, here contract tests is like this small portion here, right? So what the contract test does is that it actually verifies interactions at the boundary of an external service. Okay, so it doesn't require actually the live HTTP client to be there. It doesn't. You don't require a sub client or anything like that. So it's pretty nifty in that way. So let's go over our requirements again. Right? If it's only on that boundary, you can actually definitely capture misunderstandings from the consumer about endpoints and or payload. Breaking changes by the provider on endpoints and payload, and bugs in the consumer. So actually, that type of test would actually cover that all. So it's a kind of good solution there. I talked about some terminologies here. It kind of might have caused some confusion. It definitely caused for me when I first read about this. So you have consumer, which is a component that initiates a HTTP request to another component. So it's actually the initiator. We're not worried here about what type of method is being used. It could be a get, a post, a put, whatever. But basically, it's the initiator of the request. And then you have a provider, a server that responds to an HTTP request from another component. And then you have a contract, which I'm going to talk about a little more. And the contract is a collection of agreements between a client, a consumer, and the API, the provider, that describes the interactions that take place between them. So let's think about, how can we set up a contract-based test? Now we know some terminologies. Now we know basically, what the boundaries of this test is going to be, and what do we require for that, right? So we have 2 points, right? Two steps. The first one is define consumer expectations, saying that, hey, this consumer is going to require law type data and given maybe an example, and verify expectations on the provider. Okay. So there's a couple tools out there, cool tool out there. I have links at the end that will put it out there, but there's a cool tool that's been out there for some time called Pact.io, and they've been working on a Python version of this that is pretty neat. And so Pact.io basically provides a mock service. It's a tool that guarantees basically contracts are satisfied, right? So once you create the contract, you can check that out. And enables consumer-driven contract testing, providing mock service and a DSL. You can, and then I'm gonna go over a little more. So, so this is creating a pact contract is actually the same steps that I just mentioned for creating a contract test. Basically, you create a test on the consumer side that declares the expectations, right? We talked about expectations here, so you define those expectations. And then you create provider state that allows the contract to pass when replayed against the provider. I have some code examples here. Let's go over that very quickly. A second. So there's some code here, but the most important portion, of course, is this line here. You're basically defining the consumer and the provider objects here. And so once you define them, you can actually simply define a pact. And this is the powerful DSL portion of this whole thing, that you can say, hey, I have this pact with this given user A exists and is not an administrator. Upon receiving a request for user A, with request gets, the user A will respond with a 200 and body expected. So you define the path, the DSL pact here. And so it's usually given to define the setup criteria for the provider. And so basically you can actually create reports out of this. And this mock service, basically you send up this mock service and you can run your APIs against it. It's pretty neat. There's more examples in the links on my PowerPoint, which you can later check. But I'm going back to end-to-end testing. So again, a lot of people will ask, okay, I'm testing this, right? I'm actually testing the end-to-end test. Well, yes, you probably are testing a lot of the end-to-end, doing a lot of end-to-end testing, actually maybe covering a lot of these use cases or problems that might arise. But however, unlike contract testing, end-to-end testing requires all that box. You remember Martin Fowler's image there? It actually requires everything there to be online or maybe set up in some way, right? And subbed out some way. Because that's why it's called end-to-end testing, right? So it requires a lot of time, effort, and maintenance to actually go through and set up an end-to-end test, especially environment. So end-to-end test also causes small bugs to actually hide behind bigger bugs. So if you have an issue, you might not actually find the rest of the issues until you fix the one big issue out there in in your face. And another thing is that end-to-end tests kind of are flaky. And the thing is this, there's a lot of tools that actually make life better, but they're not all perfect. That's another problem with end-to-end testing. And it takes, as I said before, it takes a lot of time to run. So there's another tool out there called VCRPy, and VCRPy allows you to actually record a response. But the problem with VCRPy is that you have to actually have both services up and running. So you have to have a provider, you have to have a consumer, and you have to actually record those responses and then replay them back. It's pretty nifty tool, don't get me wrong. And if you want to go this way, you can use it. But with Pact, actually, you don't actually need that consumer or provider to be online and ready. You can actually start defining your contract early on, and you actually can run your test against that contract. So another nice thing about Pact is that it actually, unlike VCR, it actually gives you a given a request for will return, right? There's a nice, almost like documentation that you can use and make sure you reuse in the end. So another thing is that with Pact you can actually start with create these Pact brokers. that allows you to understand the relationship between your microservices, and that helps a lot, especially if you have like more than one microservice, like at least 6, 7, right? After a while, it gets kind of crazy. So this actually allows you to understand what's the relationship between your microservices, which is not available with BCR by. So yeah, so there's things that people are saying, okay, hey, I have Swagger, I use OpenAPI, and I use those specifications to test my API. Well, you remember the first slide where you had 2 different teams working on their own little tests? So actually, that's what was happening with them, right? They each one created their own little Swagger API, specifications, and only tested it against their own API. They didn't really test the responses that would be expected or anything like that. I mean, this is still good, definitely. Do continue, if you're using Swagger API, do definitely go continue using it. But as I said before, it doesn't actually cover all the problems that you might face. Okay, so summary. When you get out here, I just want to make sure that you have a couple points, and then you remember these. So first of all, if you do contract tests that solve all your problems, and maybe if you do contract testing, you don't need any other testing. No, that's not it. Definitely continue to do unit testing. Definitely continue to do end-to-end testing. Each has its use cases. However, contract testing is basically allows you to do very fast testing against your API or microservice and make sure that contracts are satisfied, right? Making sure that when 2 teams are working on the same different microservices, they don't break each other's stuff. So yeah. So the benefits again are it's faster than end-to-end tests. It verifies interactions at the boundary of the external service. You won't need both the provider and the consumer to be online, so you can actually have a quick integration pipeline where one portion it does a contract test, and you have faster feedback, and that way maybe you can hook this up to pull requests, which which might actually take less time. And then the thing is this contract mentality can actually allow you to allow ongoing or facilitate ongoing communication between siloed teams. So if you have a couple teams out there, either geographically or maybe because of requirement, this contract and establishing this contract and sharing this contract from a single source will definitely help out facilitate that communication and make sure that people talk to each other. So yeah, that's my time I think at this point. So I have some sources here, as I said. So these 2 last links are Martin Fowler's website. Definitely check it out. He has awesome information there. And then I put out also like Pact.io, Python Pact links, and also Pact actually has a Docker image that you can just deploy and have a service up and running and start running your API tests against it. Thank you for your time. And if you want to talk, we can talk later. As I know, in 20-minute sessions, we don't have Q&A. So thank you very much. Hi there. So this talk is about integration, contract testing, and its potential for API development and maintenance. My name is John Roach. I'm a senior software engineer in American Greetings. This slide show I'm going to show is going to be on my website, so feel free to pick it from there. And I hope to also post, give a link to it from my Twitter, and that's my Twitter handle. Feel free to go there or follow stuff. So everything starts with a story, right? The story is very simple. We had this one team that was working on a zoo application, let's say, and to cover the happy paths, and they went on to their merry way. So the developer lifecycle looked like something like this. So when a new developer came in, they sat down, read some docs on how to develop their respective API for their team. If they're on the Zoo API team, they'll be working on the Zoo API team, and they'll read Zoo API documentation. And then they'll update the test if they're doing TDD. Sometimes that's reversed, but it happens. So they first update the test, they write the code, and they run the test. So all was well. Well, the thing is that something broke. He would run the test for his API. And same thing with John. He worked on the Animals API. He only read the documents for the animals API, and he ran the tests for that and coded for that and whatnot. So the change they actually found, the error they found is actually very, very simple. Someone changed the status from no to false because it made more sense programmatically, right? Why would you use a no string instead of a false string? So, something broke. And then they have a retrospective, like every good, agile team. They sat down and said, okay, how can we avoid this in the future? So they talked about some of the good stuff they did for this. So what they had monoliths, and they said, okay, let's change this. We need to do. We need to take a different approach for certain reasons. Who knows? But the main thing is that they wanted to go with a little more modern architecture, let's say, with microservices. So they separated out these concerns, and then they create these small APIs. And here there's a zoo API and there's an animals API. And so the team had productive meetings. They discussed and nailed down the communication between these services, what's the requirements. They did some documentation. They create these end-to-end tests. Production. And the zoo app failed. Zookeepers no longer knew which animals were in which pens. Tigers, they didn't know even how many tigers they had in a pen, so that kind of went crazy. And they needed to do a rollback of the deployments, and they went to a better state. Let's go over a little bit what happened. So I said each application, each API developer would be more concentrating on their API. So like Bob from Zoo API would actually just concentrate on the Zoo API. He would only update his own tests. He would update his own code, and